Hello. Today we are going to start the next section of Unit 4, which has us graph a lot of things that are a little bit different than linear functions. The first thing that we are going to learn how to graph right now is an absolute value. So first, let's just remember what absolute value is. Whenever you're being asked an absolute value question, most of the time they won't use the word absolute value. Instead, they will use the symbols. The symbol for absolute value is two lines with the value inside of it, and that means the absolute value of whatever's inside the symbols. So, what exactly is absolute value? Absolute value is a number's distance away from zero. So, for example, there in red, you see that we're trying to find the absolute value of -3. If you counted how far -3 is from zero, it's 3 times away. Not -3 times away, because we can't move a negative distance, so we just say that it's +3. If you want to know what the absolute value of 5 is, that's 5 places away from 5. And the absolute value of 0 would just be 0 because it's no time away. So, we're going to have our first practice at considering a function where f of x is the absolute value of x. So if we are asked to find f of -7, that means we're being told that x equals -7. And remember, our function was the absolute value of x, but now our x is -7, so we're trying to find the absolute value of -7. And how far is -7 away from 0? It's just 7 places away. Now, if we're trying to find f of 0, that means that we know that x equals 0. And we're trying to find the absolute value of 0. Which 0 would just be 0 places away from 0. B, find f of 4. That means that x equals 4. And we want to know what is the absolute value of 4. And 4 would just be 4 places away from 0. And lastly, what is the absolute value of -12? That means we're trying to find out how far -12 is from 0, which is just 12 places away. Pretty simple. We could have also just typed into our calculator that x equals these values and then type in the function. We could have also typed this into the function into the graphing key, then go to table and look for these x values. All right, so now let's get our first practice at graphing an absolute value. Here we are being asked to graph just plain old the parent. It's called a parent function when there's no numbers added to it. We're just graphing the plain old absolute value of x. So I'm going to type in absolute value and put my x, enter. This is a picture of what absolute value is. Absolute value v, means that anything with an absolute value symbol is going to look like some sort of a v. Now, I'm not told what domain to use here, meaning I'm not told what x's to use. I just took some negative ones and some positive ones. So let's go look at our table. And -3 would be 3. -2 is 2. -1 is 1. 0 is 0. Ooh, and then they start to repeat again. 1 is 1. 2 is 2. 3 is 3. You always want to find this, I call it like the middle point where the stuff around it starts to repeat. And if you put that in the middle of your table and you have a few points above it and a few points below it, you'll get a really nice looking graph. And this right here, this point is called your vertex. That's the middle point where everything around it starts to repeat. So let's graph this. -3 up to 3. -2 up to 2. -1 up to 1. 0, 0, 1, 1, 2, 2, and 3, 3. Perfect. Now we are going to connect these points a little bit longer since we know it keeps going. And we are going to put some arrows. And this is the absolute value function. Once you add numbers to it, it will shift the v around, maybe make it go upside down. It could do things like that. But for right now, that is what the parent, the basic, the no number absolute value function looks like. Now let's answer some questions on this. First, let's answer what is the minimum. What is the lowest point here? It would be right here, which is the point 0, 0. Good. Now, what is the domain? If you remember, domain means x, which means how much to the left. This is my leftmost. I wouldn't say -4. I would say negative infinity because it goes all the way to the left since there's an arrow. And how much to the right does it go? It goes to positive infinity. Now let's talk about our range. The lowest point we have on our graph, the lowest the point the graph ever goes is 0. That's an actual point, so we put square bracket. And how high does it go? It's going up to infinity. Perfect. And now, we could talk about intervals of increasing, decreasing, and constant. There is no place here where the graph is constant, but there is this place. This side of it would be decreasing. So, from the left, it starts decreasing at an arrow, which is negative infinity, and then it stops decreasing at 0. Because at 0, it also then starts doing something else. When it's doing two different things, we put an arrow. And now let's look at this side. This side is increasing. It's going up. It starts increasing at 0, and it stops increasing at positive infinity. And that is some of the key features of our absolute value graph. All right, now we are going to answer some multiple choice questions on this. So, let's look at this first question. What is the graph of the absolute value of x plus 2? Well, the beautiful thing here is that we could literally just type that into the calculator, x, and make sure we put our plus 2 on the outside. And then we could graph it, and we get a picture that looks like a V. That's a little bit up from 0. Choice 3. If I just know that absolute value, these symbols, gives me a V, I didn't even really need to type it in the calculator. I could have automatically found the answer, but no problem at all. So choice 1. This is called a linear function. This only happens when you have an x and some number. No exponent, no absolute value symbol. Number 2 and 4, those are both called quadratic, and those only happen when you have an x squared. There could be coefficients, there could be other numbers, but you have to have at least the x squared. The 2 has to be your highest exponent. All right, let's look at the next one. Let's type this in the calculator. Absolute value of x minus 2, enter. The minus 2 is inside. Let's look at it. Ooh, I see that the base, the vertex, the middle point, went to positive 2, which is choice 4. Good. All right. This question, which equation represents the function shown in the graph? Well, let's type these all in. Might have to type a lot in, we don't know yet, let's see. So, absolute value of x, I'm typing in answer choice 1, on the outside plus 1, go to graph it. Wow, we actually got lucky that the first one is the correct answer. What I like to do is I always look where my vertex point is. Here it's up 1, and on the picture of what we just graphed, that is the same looking picture. All right, next question. The table of values can be modeled by which equation? So what we're going to have to do here is we're going to have to type in each answer choice, and we're going to have to see which one makes sense. I don't think answer choice 3 or 4 makes sense because I never seen one where I had the y, so it's not going to be either of those. Okay, let's look at answer choice 1. The absolute value of x plus 3, and let's look at the table. I'm going to go up to negative 2. Up, that's not it, because it's not negative 2, 1, so it can't be choice 1. And let's look at this one. The absolute value of x plus 3. And let's go to the table. Negative 2, 5, negative 1, 4. That looks great. This is our answer. These are easy questions that we can get right, no problem. Let's look at this next one. What is the minimum value of this? Let's type it in. The absolute value of x plus 3. And then let's put minus 2. Let's look at the graph. What is the lowest it ever goes? Well, it definitely goes to the negative side, so it's not going to be choice 2 and it's not going to be choice 3. And how much does it go down? It goes down to negative 2, which is choice 1. Good. Alrighty. Now we are going to do 3 long response regions questions. Let's do this first one. They tell us on the set of axes below, graph this. So let's type this in the calculator. The absolute value of x plus 3 inside the symbols. And no, x minus 3. I almost made a mistake. And then the plus 2 on the outside. And they don't tell us what numbers to use for our table. So what I like to do is I just like to find that vertex point and put some above the vertex and some below it. So let's see. 8, 5, 4, 3, 2. Ooh, 2, 3. This is the point where it starts repeating right here. 2 doesn't repeat, but the rest does. So I'm going to put that in the middle somewhere. And I'll do some above it and some below it. Perfect. And now I'm going to go plot these. 0, 5. 1, 4. 2, 3. 3, 2. 4, 3. 5, 4. 6, 5. Now, they didn't tell me any domain to use, which means it's all the possible numbers. So I'm going to put my lines a little bit longer, and I'm going to put some arrows. Very nice. Let's look at the next question. On this set of axes below, graph this, include this interval. All right. When they tell us what interval to use, that means that is the definite x values they want us to use. So here, they want us to start at negative 7, and then they want us to end at 1. So let's go do that now. Perfect. All right, we got to go type this in. 2, then absolute value of x plus 3. Let's go to the table. Negative 7 is at 8. Negative 6 is 6. 4, 2, 0. This is our vertex point, and then everything afterwards starts repeating. All right. So they chose just like I would choose, where you have the vertex and then you have a few above and a few below. It'll be a nice looking graph. Let's do this. Negative 7, 1, 2, 3, 4, 5, 6, 7, and let's go up to 8. That's 6, 4, 2, 0, 2, 4, 6, 8. Perfect. Now, the only thing here is, when you go to connect these points, you do not extend them past that negative 1 and that 1, because that's how far to the left we want to go and how far to the right we go. And we do not put arrows because they tell us where to start and where to stop. So that is all. And let's look at the next one. Graph this over the interval negative 8 to 0. So again, they tell us where to start and they tell us where to stop. So these are going to be the points we use. Okay, let's go ahead and graph this. All right, absolute value of 1/2 x plus 3. Good. And let's go to a table. Negative 8 is 1. Negative 7 is 0.5. 0. And then it starts repeating again. 0.5, 1, 1.5, 2, 2.5, and 3. Okay, this is our vertex. The points around it start to repeat. As you can see, there's a few above but a lot below, so it's going to be a little off-centered, your graph, but it will still look like a V, don't you worry. So we are only going to graph the whole number points. You do not have to graph decimals if they are not the two endpoints. You always have to graph the endpoints no matter what they are. But if we have some that are whole numbers, let's only graph the whole numbers. Perfect. And we're just going to connect them. We're not going to extend it, and we're not going to put any arrows. And this is our final graph. And that sums up our lesson of graphing absolute value functions. And those are some multiple choice and long response Regents questions.